Bismillahirrahmanirrahim. Today we'll conduct a session on polymorphism, which is one of the most powerful feature of object-oriented programming. Before this topic, we have already discussed several different concepts about the inheritance. So the basic feature of inheritance was to reuse the data members and the member functions through the child object. So a child object used to access the methods or the data members of a parent class or the base class. So polymorphism is a bit reverse of inheritance, but the inheritance is required in polymorphism as well. We'll discuss the several different concepts and several different features of polymorphism. Let's move on. This is basically a class hierarchy in which you can see a shape inherits its features. When I call a features, it includes both the data member and the member functions to its child classes, which are circle, rectangle, and triangle. So this is basically a hierarchy in which the shape is inheriting its several different features. So where comes the polymorphism? First, I will explain you and introduce you with the notion or the concept of polymorphism, what it is all about. Polymorphism is the ability of an object to take on many forms. So focus on this point. Polymorphism is the ability of an object to take on many forms. So it is related to the object. An object can take on different forms. When we call it different forms, that means if we see the hierarchy of a parent and a child class, so the object may be allowed to access the features of parent class and also the child class features as well, that we have been using in the inheritance as well. But in that case, during the inheritance, we used to declare object of the child class, and through child class we used to access the members of the parent class. But in the polymorphism, we'll see the reverse of this particular concept. Okay. The most common use of polymorphism in object-oriented programming occurs when a parent class reference is used to refer to a child class object. As you can see, actually the relation is different. No, inheritance is top to the bottom, but we are going to declare object of a parent class, and through which we'll be able to access the features or the functions of a child class. Let's see how does polymorphism work. When a base class pointer is used, as you already know, we're following Java as a programming language, so there is no such thing pointer in Java. But the reference is there. When we talk about the reference, that means there is some kind of the addressing mechanism in which the addresses are held in an object. So the base class pointer, as you can see right here, the base class pointer is used to store one of its children. So basically we are going to declare object of the base class, and it will be holding a reference of a child class in any method in the base class can be handled. However, any methods that are not declared in the base class cannot be called. So what will happen is we are going to declare object of base class, and through the object we'll be able to call the features of the children, provided those features are also declared in the parent class as well. So that means the same name and the same signature should be there in the parent class and in the child class as well, but we'll be calling through the base class object, the main focal point. That is the inverse of the inheritance. You must consider it. As you can see right here, the polymorphism in which we have an object of a circle, and which is declared through a new, and through the polymorphism what you are doing is there is a different class shape S, but we are assigning us the object of a different class. As you can see, the circle class object, when we use a new notation with it, so that means there will be a virtual object here that will be assigned to this particular object. So the object will be for the circle, but will be assigned to the object of shape S. So this will happen, and this is the polymorphism. So in that case, if you follow the hierarchy, So this will be your parent class and this is your child class. So child class object being stored in the object of the parent class. This is the polymorphism. Later on we'll see how we can manipulate the functions through these objects. So when we'll call it, what type of the function will be called. So the object reference variable can be a superclass. As I already told, this is the object, the one that is referring, that is the superclass or the parent class of the actual object, and does not work the other way around. Circle is the shape, but shape is not necessarily a circle. So the inverse is not possible. That means you cannot store the object of a parent class in a child class object. So it only happens through the inheritance, but the child object will be stored in the parent, because you see a shape is a general class, and this is the circle is the specialized class. So specialization can be incorporated in a generalization, but the generalization cannot be incorporated in a specialization. That's the concept you need to follow. So the polymorphism is an object-oriented concept that allows us to create a versatile software design. It is the ability of an object to take on many forms. So as you can see, the object can take on many forms, because when we'll declare the object of a parent class, it can call the normal functions of the parent class as well, and through that object we can call the child class features as well. In Java language, polymorphism is essentially considered in the two versions. So now we are dividing the polymorphism in these two basic concepts. First one is the compile time or the static polymorphism, and another one is the runtime or the dynamic polymorphism. So when we call the static and the dynamic, that is with respect to the compilation. So one is the compile time and one is the runtime. In the static polymorphism, there is a concept of method overloading, but in the dynamic polymorphism we have a method overriding. Overloading and overriding, as we have already discussed it before, but we'll discuss them in detail in these lectures as well. So this is the static binding and the dynamic binding. So now we'll discuss the static polymorphism and the dynamic polymorphism in more detail. But before that, we need to understand what is the method overloading and what is the method overriding. Okay, to differentiate between these two concepts, overriding and overloading. Overriding, let's discuss the overloading first. Overloading, the concept happens in a same class. So it won't happen in the more than one classes or the inherited classes. So within a class, you have two different features or the functions. They are declared with the same name, but with the different signature. So the signature is different right here, because as you can see, this is accepting a one argument, and this particular function is not accepting any argument. This is the overloading. You are overloading the functions. You might have already seen it in the classes when we have declared several different constructors, and the constructor names are same, but their arguments are different. So we have already discussed the constructor overloading concept already in the classes as well. So it is happening within the same class. That is the important point to note. Whereas the overriding will always exist in the inheritance. As you can see, the class dog being inherited through the extend keyword to the home, that is the child class. So in that case, the inheritance is there, and we're discussing the overriding. And the emphasis on that word overriding, because there is some kind of ride and someone else ride the same thing. So that concept becomes the overriding. You are overriding. Someone is riding, and another person who comes and ride it, and that is the concept of override. So we'll see how overriding is actually happening. In the overriding concepts, you have a child class and a parent class. In those both classes, they have the same function and the same signature as well. That is must. As you can see, same method name and same parameters. So the important concept is it should have the same name and same signature as well, but happening in the parent and child classes both. So that concept is the overriding. Overriding, we'll see how it overrides the feature. When we'll call the feature through one of the object, and it should call an appropriate function. So we'll see how it overrides basically, because it happens when through the child object when we call the bark function. So which particular function will be called, we'll see through the overriding concept. Okay, first let's discuss the static polymorphism, or the method overloading. Remember, overloading is happening within the same class, and when you have more than one functions, they have the same name and the same signature as well. This is used to write the program in such a way that the flow of control is decided in a compile time itself. So what's happening is, it will decide at the compile time itself, right? Because you have called a function, one accepting one argument and another one accepting the two argument, and they both have the same name, and whichever the function will be called, so in that case it will call the appropriate function. So that decision is being made at a compile time, because you're at the compile time is the time when you are when you have written a code, and your compiler is compiling, and it will determine which particular function it will call. Because when you will pass a one argument to a function, definitely it will call a function that is accepting a one argument. And when you are sending the two arguments in a function, provided they have the same name, that is actually the precondition of the overloading concept. So it will decide at the compile time as well. It is achieved using a method overloading, as I already discussed it in detail. What is the overloading? Same name with a different function. In the method overloading, an object can have two or more methods with the same name, but with their method parameters are different. So that becomes a signature. I have already discussed. I'm not going into the more detail in it. These parameters may be different on two bases: type of the parameter and the number of the parameters. So that is the thing that makes it a different signature. Okay, let's discuss it with the help of an example of the static polymorphism. As you can see, I have two different classes. One is the simple calculator and another class is the demo class. But the important thing to note is that there is no inheritance relationship in here. So in the simple calculator, I have two different functions with the name add, but they are accepting two different arguments. One is accepting two arguments and another one is accepting the three arguments here. So in the static polymorphism, polymorphism basically, as you remember, we have already discussed a concept that we can call several different variations of an object, several different variations, in which you can see there is one variation. When we are calling add function, the two argument, it will call this particular function. And when we are calling this function with the three arguments, it will call this particular function. So there is a variation of the features of this particular object. So there is the important thing to note, this object is basically the object of the simple calculator right here. So it is calling the function the same name but with the different parameters. So this is the static polymorphism. Because it is static, it is already predetermined which particular function will be called, and it will be determined at the compile time, because the compiler will decide that is going to call the two parameter function and this particular function for the three parameter function. So it is predetermined at the compile time. So this is the static polymorphism. The polymorphism concept is that you are actually accessing different features with the same object, provided they have same name but the different signatures. That becomes a polymorphism in context of static polymorphism. Okay, compile time of static polymorphism, we have discussed it. Overloading, where comes the overloading? The same name but with the different argument or the different signature. Even the data type is different, that becomes a different signature. So this is the overloading. As you can see here, when we call this function with 5 and 5.0, 5.0 is referring to double and this is the integer, right? So that is the overloading. So it is predetermined which particular function will be called. Why overloading method? The thing is that you require basically you want to do several different things, but the names or the common, then you require overloading. As an example, in the Java you might have seen the println, double, println boolean, println string. So there are different features you can use with the same name but with the different signatures. So that is the overloading. So it will be predetermined what type of function will be called. So I'm not going to the more detail in it. Another reason to overload a method is you may want to do the same thing with the different kinds of data. For example, these are the same functions, the print information, no argument being accepted. But right here, the functionalities are different. This is printing the personal information, this is also printing personal information, but the difference is here. This particular function is printing the grades, and this is the research interests as well. So their functionalities are same, but their names are functionalities are different, but their names are same, and the inheritance relationship also there. So it will be predetermined what type of function it will be called. We'll discuss some uppercasting and downcasting because it is compulsory and it is required in polymorphism as well. So right here it's saying uppercasting is legal, downcasting is illegal. So what is the uppercasting and the downcasting? Uppercasting basically when you are going from the bottom toward top. In case of the inheritance, if we discuss, then the inherited class to the base class when we'll go, or when we derive the objects, so that is legal, because through the child object you can access the features of the parent access. So that is a legal procedure. So that becomes the uppercasting. You're going from the lower class to the upper class, or in contrast, the downcasting is illegal. Downcasting means through the generalization you cannot access the specialization. So you have a parent class, and through the parent class object you cannot access the features of the child. So that becomes the downcasting. That is illegal unless you explicitly cast it. Right? So I have discussed uppercasting and downcasting with respect to the inheritance, but if we consider the data types, the same procedure actually is applicable in with respect to the data types as well. As you can see, I have declared int I, and there is another variable double d. So I am assigning d 5. So this is legal procedure. 5 is basically the integer, whereas usually you already know the double, basically it comes in points with the maximum size of the data. So from the that is basically the uppercast, because if you see the size required for the data types, for the integer it's 32-bit, for double it's 64 bytes. So as you can see, this is the integer utilizing a 32 bits of the data. So 32-bit being accommodated in the 64 bits of data. So it can hold a 64-bit, this D. So 32 can be accommodated or can be adjusted in the 64 bits. Whereas this is illegal. Why it is illegal? 3.5 is basically a double value, right? So it will be comprising of 64 bytes, double. So from the 64 bytes, you are actually accommodating in 32 bits, right? Sorry, bits. This is 64 bits into 32 bits. So 64 bits cannot be accommodated in 32 bits. The common sense says that. Until and unless you explicitly typecast it. So I am typecasting it. So 3.5, no, it becomes the legal. 3.5, when we will typecast it into integer, no, it can be accommodated, that becomes illegal. So this is basically in context of the downcasting and the uppercasting. This is the uppercast, right? The uppercast cannot go into the downcast, right? Basically this is illegal. So the upper class being actually casting in the down class. So this was the lower class, 5, 32 bits, it's lower, and this is higher. From lower to higher, it's legal. So that is downcasting and uppercasting. I have discussed it with respect to the variables and with respect to the inheritance as well. Right here, as you can see, I have a function declared with the double. It is accepting a double argument, but when we are passing the 5 parameters, it is integer. So 32-bit can be accommodated in the 64 bits. So that is the legal procedure. It can work, but the reverse, if we declare an integer here and we are sending a double value, no, it cannot be applied to the double value, because 64 bits being inserted into 32 bits. So that is downcast and the uppercast concept. Okay, Java used the more specific methods. I'm not going to the more detail in it. Let's come to the main focal polymorphism concept, and the other part was the dynamic polymorphism. And the dynamic polymorphism is related to the method overriding. Overriding this concept that we have already discussed. In the method overriding, there is a relationship of inheritance. That is must. So let's discuss the dynamic polymorphism, how it is applied and how it works. Feature that allows a subclass or child class to provide, that is the focal point. Features that allows a subclass of the child class to provide a specific implementation of a method that is already provided by one of its superclass or the parent class. Right. The feature being discussed is that with respect to the dynamic polymorphism, the important concept is that the features must be same in the child class or the subclass or the parent class or the superclass. So when we will access a particular method through appropriate object, we'll see how it happens. It depends on the type of the actual instance created on trend. So that is the crucial point or the crucial sentence. It will depend what type of object we are using to access an appropriate method of a child class or the parent class through it, and we'll see later on. When an overridden method is called through the reference of a parent class, then type of object determine which method to be executed. So in the dynamic polymorphism, things are happening dynamically, because through the parent class object, we'll try to access an overridden method and we'll decide which method will be executed at the runtime. So that will actually be determined at the runtime. Thus, this determines is made at the runtime. Let's discuss it with the help of an example. As you can see, I have two different classes. We're discussing a dynamic polymorphism, keep in your mind. ABC is a class, right? It has a method, my method. So I'm just printing it, the overridden method. Overridden method. Follow the words. Overridden method. I have another class, XYZ. So ABC basically being extended. So that is the parent class. So we are extending the class XYZ, right? So there is an inheritance relationship in these two classes. But the important point is that the method, my method and my method, they both are same. So when the methods are same in parent class and the child class, that becomes overriding, right? This is overridden and this is overriding method, because this method is the overriding method. Okay, I have a main function right here. No, the important thing to note is I am going to create object of XYZ, and remember XYZ is my child class. I have created instance through the new keyword. Do not focus on the left side of that assignment, just focus on the right side. Through the new XYZ, when we'll use a new of the class, so that is the constructor being called, through the new, it will create a new object. Object of what type? XYZ, right? So that object is basically being created for a child class. So we have created a child class object, and now comes to the assignment operator. We are assigning the child object to the object of parent. You got the point? The child class basically is creating an object, and that object is being stored or assigned to the object of parent class, right? This is basically happening due to the inheritance relationship. In a normal normal way, if there is no inheritance relationship, you cannot perform this particular thing, right? Because it cannot accept, because you already know the typecasting. We have already discussed the upper caste and the downcast. So I will introduce the same concept right here. What we are doing is we are actually uh, assigning the child object to the parent object, right? So we are assigning the generalization to the specialization, which was illegal. But now we are actually through the dynamic polymorphism concept, that becomes the legal procedure, and this is basically uh, due to the inheritance relationship is being actually made possible. So we are actually typecasting it, right? Here we are typecasting it. And when we call my method through the object, so remember the object is basically of the parent class, right? And we have actually typecasted or the stored the child class object right here. And when we'll call the object dot my method, and what will be the result? This function or this function will be called, right? The answer will be the overridden method, match the colors. This particular method will be called. We are actually calling my method. Methods are same in both of these classes, and through the parent class object we are calling this my method, and my method, the one will be called of the child object. So that is the dynamic polymorphism. It will decide what type of method will be called. So if there is a method right here and which is not written in the child class, so it will call its normal method. For example, there is a my method 1 and it is declared in ABC class only, not here, right? There is no overriding here. So in that case, the object will call its normal procedure or the function. So as you can see, this is the polymorphism. Through the one object, we are actually calling the several different functions, and this is the polymorphism, accessing the features in several different ways. So this is the polymorphism. This is the dynamic polymorphism. I hope you have understood it. If you have queries, you can contact me through the Google Classroom, and I will help you to answer it. We'll continue this session more in the more details. Try to practice the polymorphism and try to introduce several different functions, and try to play with that code. You will learn a lot. Thank you very much. See you soon.